A very warm welcome to you all. And as you know, this webinar is taking place as part of Maths Week England, although you are welcome if you come from beyond England. And Rich is delighted to be taking part in the webinar, in Maths Week England, as part of all the, I want to say, festivities that are taking place. My name is Liz.
And I'm Charlie.
And we are going to be working mathematically with you this morning. This week, NRICH is going to be publishing each day one or two problems for upper primary and lower secondary. And we're going to invite you to work mathematically on them over the week. And at the end, on Friday afternoon, we'll be publishing the solutions. And the purpose of this morning's webinar is to have a go at Monday's problem all together so we can begin your working mathematically week. We want to make it very clear that working mathematically, being a mathematician, is not about getting everything right really quickly first time. We're expecting mistakes. Charlie and I often make mistakes as we work on mathematical problems, but what we'd really like you to try and do if you do make a mistake is think about how you can learn from it and try not to make that mistake again. So please don't worry about speed or being right first time. We hope that even after this morning's webinar, you might revisit the problem we're going to have a look at because there'll still be plenty to think about. And right towards the end of the webinar, we'll show you the page where we have published the link to today's problem and teachers where you'll be able to find the links to subsequent problems over the week.
Yes, perhaps it's worth saying the problems that we've chosen for you for this week are problems that don't have just a single solution.
That's right.
There are many aspects to the problem. We call them rich tasks because there's plenty to explore, there's plenty to discover. And actually, some of the problems are worth taking home and discussing with family or friends. So they're not just one solution kind of, one answer kind of problems.
Absolutely. Thanks, Charlie. Okay, so shall we get going? I hope you're all ready to work mathematically. At various points, so we probably should say, teachers, at various points during the webinar, we'll be inviting classes to work on the problem and the challenge that we're setting. And then after a particular period of time, we will invite you, please, teachers, to post on the chat, some examples of what your class or the children you're with have been thinking about so far. So teachers, probably, we imagine that you might be circulating around the room as students work. And then when we invite you, you could post some examples on the chat, please. That would be wonderful. Right, Charlie, let's go. Here we go. So the problem that we've chosen for Monday is one of our favourite problems at NRICH. It's called dozens. And as Charlie said, it's a wonderful, rich mathematical task. There are many elements to this challenge. We're starting here. So we are being invited, Charlie, to enter the largest three-digit multiple of 2 that we can, that uses the digits below, and another one that we can choose. Now, just quickly, a multiple of 2. Okay, so a multiple of 2, that means we need an even number, doesn't it? Okay. So we've got a 2 and a 3 already, but we can choose one other digit to make our three-digit multiple of 2 as large as possible. All right, so let's have a think about this. We've already got an even digit.
So we could add an 8 and have 238, for example.
Okay, well, shall we try?
Yes.
So I can enter 238. That's definitely an even.
And it uses the 2 and the 3.
It uses the 2 and 3. Okay, we're being told by the computer, I just clicked check, that we're correct. It is a multiple of 2, but actually we could find a larger one.
But maybe if I put the 8 in the hundreds column.
Okay, nice. Let's try again.
And then the 3 and the 2.
Yep.
I'd still get an even number, and I'm still using the 2 and the 3.
And it's much bigger. So let's see. Okay, but there is a larger one. How can we get bigger than 832?
Maybe I don't need to use an 8.
Okay.
If I used a 9 instead.
Right.
I could get
932. And although 923 is bigger, that's not even, is it? So.
And 923 is not bigger.
It's not at all. What am I talking about?
Well,
okay, there we go.
Mistakes.
Yeah, there we go. I'll learn from that. Good. Yay! Okay, brilliant. We got there. We got there. And look, in the chat, people are contributing for us. Remember, we always have to use the two digits that are given to us. So in that case, it was a 2 and the 3. So we can only get to choose one other digit.
In the chat, some people are writing numbers like 998 or 938, and what those aren't allowed because they are not using the 2 and the 3 that we were given.
That's
You
right.
have to use the
That's
two
right.
numbers that you're given
Yep.
and an extra one. And the one you use can be one of the ones you've already got.
Yes,
So
you can repeat a digit. Yeah, you're
if
absolutely
we've
right.
been given a 9 already, we could have used another 9.
Good, good. Okay. So, you know, even numbers, multiples of 2, that's, I think that's not too challenging.
Shall we give everybody a chance to do one more on the chat?
All right, let's do that. So I'm going to click on down here. We're going to set up another challenge with multiples of 2. Okay, so this time you've been given a 7 and a 6. Over to you in school. Teachers, please post your classes suggestion. What is the largest 3-digit multiple of 2 that you can make using the 7 and the 6 and one other digit? We seem to have quite a lot of agreement here, Charlie.
Good, good. So maybe we should go on to multiples of 3.
I think everybody has said 976. Fantastic.
Actually, you know what? That was very similar to the one before.
It was, wasn't it? Because we had, yes, go on then. Do you want to set one more? Go on then. Go on then.
That is not quite so. Okay.
Okay, try this one.
We've got 2 1s.
So you can choose one of the digits. What's the largest multiple of 2 that you can make this time? Remember, we've got to have an even number. This was a good choice, Charlie.
Okay, we're getting a lot of agreement now.
Yeah.
Some disagreement at the start.
Because I think we just momentarily, we'd got into the habit of putting a 9 in the hundreds, haven't we? And we'd forgotten what.
So 911 is the largest 3-digit number that we can get if we're not constrained by having to make it even.
Even. Fantastic. But as you say, the rest of you, many of you now are saying 118. Fantastic. Okay, shall we up the ante a bit, Charlie? Okay, what we're going to do now is we're going to think about multiples of 3. Charlie, in terms of multiples of 3, I mean, an even number is quite easy, you know, to figure out. Sorry, it's quite easy to tell whether a number is even or not, a multiple of 2. How about multiple of 3? How might we?
Okay, so the rule is
yeah.
that if you add the digits
yes.
and it comes to a multiple of 3, then the whole number is a multiple of 3.
Okay, so for example, if I had 24, I would add the 2 and the 4 to make 6, which I know is a multiple of 3.
Yes.
And that works even when we've got more than 2. I used a 2-digit example, but we could
yes. Now, if you scroll to the top of this page,
yes.
you can see that there is a link to an article called Divisibility Tests.
Yeah.
And in that article, Tim Rowland explains what the rules are, not only for numbers that are divisible by 2 and 3, but for 4 and 5 and 6 and so on. So teachers, you may want to have a look at that with your students as you study different divisibility tests.
Yeah.
I mean, a very brief explanation for multiples of 3 is, for example, when you think about why the number in the hundreds digits tells you something about multiples of 3. So we know that 99 is a multiple of 3.
Yeah, that's
so
an obvious one.
100 is one more.
Yes.
So 100 is one more than a multiple of 3.
Yes.
And so 200 would be 2 more than a multiple of 3. 300 would be 3 more, which is a multiple of 3, and so on. And so whatever number you get in the unit in the hundreds column will tell you something about how many more than you are than a multiple of 3. And likewise for the number in the thousands column, because 999 is a multiple of 3, 1,000 is one more. Anyway, Tim explains it slower and better than I have, but
that gives you a bit of an insight.
Feel.
Yeah. So here we go. We've been given a 5 and a 3, and we've got to make a multiple of 3. So many of you have already popped some suggestions in. We don't have so much agreement this time. So let's have a little think about this together, shall we, Charlie? We've got the 5 and the 3 already. We add up to 8. But we need our third digit, when also included, to make a multiple of 3 in total. Well, I could add a 1.
Wait, I want to make it as big as possible. So I want to try 9 if I can.
Oh, it's good idea. Good idea.
But
Right.
9 and 8 add up to 17,
Yeah.
which is not a multiple.
Right.
So I'm not going to be.
No.
Ideally, I would have wanted to put a 9.
A 9. So what about if I chose an 8 instead
8
then?
and 8 is 16, which is not a multiple
Still
of
not
3.
a multiple of 3.
But 7 will be.
Right. So a 7 and a 5 and a 3, that is going to add up to make a multiple of 3.
15.
Right. And if we want to make the 3-digit number as large as possible.
7 in the hundreds column.
Right. So many of you are agreeing. And again, don't worry if you made a mistake first time round, because you may not be familiar with multiples of 3, and this just needs a little bit of a different way of thinking. Let's check. Okay, wonderful. Right. What about asking everybody else to have a little go, Charlie?
You can click on the
three. I always forget that. Thank you. Okay. Oh, right. So here we've got 1 and an 8. Which digit would you put with the 1 and the 8 to make the largest possible multiple of 3? Have a little think in your classes and post on the chat when you've convinced each other. We don't have total agreement this time, Charlie.
No, I saw a 681.
Yes.
And the digits there add up to 15, which is a multiple.
That is a multiple of 3, yeah.
But even with 6, 8, and 1, I could make a larger multiple of 3 because I could put the 8 in the hundreds column.
Computer agrees.
I also saw a 183. So the 1 and the 8 are being used, plus a 3, multiple of 3. The numbers add up to 12, which is a multiple of 3, but there is a bigger one.
There is a larger one.
And a lot of people have realized you could put 9. Now, some people wrote 918.
Which is a multiple of 3.
Which is a multiple of 3 and uses a 9.
Yeah.
But you can go a little bit larger than that.
Yeah.
By putting the smallest number in the units column.
Right.
So
brilliant.
Well done to everybody who got 981.
Fantastic. Fantastic. Should we do one more of those, or should we move on? We think we can challenge everybody, Charlie. Yeah?
So multiples of 6 is connected to what we've been doing.
Yeah. Okay. So we're going to move on to think about multiples of 6. Charlie, in order to have a little think about this, instead of sharing the screen, I'm going to, oh dear, I've momentarily lost my, hang on. Why am I being so slow here? Oh, there we go. This is what we wanted to see. So Charlie, we've written here the multiples of 3.
Yep.
And we're going to have a little think about multiples of 6. So which of these are multiples of 6? Well.
So I've got the 3 times table. Which we've done.
We've had a look at.
So will you tell me which the multiples of 6 are?
Yeah, okay. So 6 I definitely know. And 12 is 2 6s. 18 is 3 6s. 24 is 4 6s. 30 is 5 6s. And then 36 is 6 6s. 42 is 7 6s, and so on.
All the 6 numbers in the 6 times table are appearing on
our multiples of 3.
Multiples of 3. So what is special about the numbers that I've circled compared to the numbers?
Compared to the other ones?
Yes.
Now, in your classrooms, I hope you're shouting at the, or perhaps not shouting, shouting at the screen. I think these are even multiples of 3.
So the even multiples of 3 are also multiples of 6. The odd multiples of 3 are not multiples of 6.
Right. So we know that, we've said that even numbers are multiples of 2. So a multiple of 6 is a multiple of 2 and a multiple of 3.
So a number like 600
Yes.
is a multiple of 6. It's even.
Yes.
And the digits add up to 6.
So we know,
but we can do more complicated numbers like that.
Yeah. Yeah.
Like, I don't know, 942.
Okay, 942, the digits. Okay, so it's even. I can tell that straight away.
Because
the
I've got a 2 in the units column.
942, 9 plus 4 plus 2. Yeah, that makes 15, which is a multiple of 3. So that would be a multiple of 6.
So we can work with really quite big numbers.
Yeah, okay.
So, yeah.
So can you, I think, Charlie, you've got a rather nice way of picturing this, which would be, I think it would be really nice to have a little look at.
This is where we're going to cover.
I think we need, we were going to try and cover with 2 bits of paper. If I move this one to the side.
Okay.
Yeah.
Go for it. Okay, so I've got 3 crosses there to represent 6. Did I say 6 crosses?
You said 3 crosses.
Yeah, that's what I thought.
Me slightly, because I think there are 6 crosses.
Yeah, there are 6 crosses.
Good.
And what's quite nice is I can see why 6 can be split up into 2 equal columns.
Yes.
So 6 is 2 lots of 3. I can share 6 equally between 2 people.
Yeah.
But if I've got 2 6s, I can still share that equally between 2 people.
Right. 1 column here and 1 column here.
And if I add another 6, and if I keep adding 6s, I will always be able to share them equally between 2.
Nice. That's really clear. Okay, but
so that shows why any multiple of 6 is going to be an even number.
So what about multiples of 3? What can we think about it that way?
Okay, so let's get rid of that distraction. Okay, so can you move the sheet sideways? So we've got 3 rows here, which shows 6 can be shared equally between 3 people. And now we've got 2 lots of 6, and that's still can be separated into 3 equal rows.
Nice.
And as we move to the right, with more and more 6s, we're always going to be able to share 6 equally between 3 people.
Really
so
nice.
6 is always divisible by 3, so it's a multiple of 3.
Yep.
And 6 is also always divisible by 2, so it's always an even number.
Fantastic. Really nice. The power of the array is, demonstrated there. Thanks, Charlie. All right. So now we've had to think about how we can tell whether a number is a multiple of 6. Let's go back to the interactivity. Just bear with me. Okay. So that was our multiple of 3. Here we go. So now we've got, we're being challenged to find the largest possible multiple of 6. We're allowed to include a digit of our choice, but we've been given a 3 and a 9. So I wonder, Charlie, now we've just said that multiples of 6 have got to be even.
So I think the missing digit's going to have to be an even number.
And it's going to have to go in the ones.
In the units column,
yes. Yeah. So
shall we leave everybody to have a think about this?
Let's have a think.
What's the largest multiple of 6 that uses 3 and 9? It's got to be an even total and a multiple of 3. Wow, lots of agreement here. So the digits have to add.
Oh, we've got a couple.
little bit of a
A little bit of
disagreement.
disagreement, but that's a healthy thing. A bit of disagreement means that we have to really think about our reasoning to help convince others of our thinking.
So somebody wrote 996, which is a large multiple of three,
It
and
is.
it's even, but they didn't use the number three.
No, which we have
So
to
you
use in this
have to
case.
use
Yeah, yeah,
both digits.
yeah.
Otherwise, that would have been a really good answer. And I think it is the largest one that uses just one of the digits that we've been given.
Mm-hmm.
And actually, I think it's the largest you can do with three digits anyway. The largest multiple of six.
Yeah, I think you're
Yes.
right. Yeah. Great. Okay, we still got a little bit of disagreement. Don't forget that we're finding multiples of six.
So 939,
It is a multiple of
three,
three,
but it's not
but
even.
it's not even, so it won't be a multiple of six. Yeah.
So
Okay, so shall we have a little think, Charlie? So the 3 and the 9 all together, they're making 12, which is already a multiple of 3.
so I think I can add a 9,
Right,
which is another multiple of 3,
but
because all these multiples of 3 will add to a
would add to
multiple
a
of 3.
multiple of 3, but that's not going to give us an even number.
No, so
So,
9, yes, 9, 9, and 3 add up to 21. But then I've got three odd numbers.
yeah, that's right.
So I think I'm going to have to add a 6.
I think so, to maintain the multiple of 3-ness.
Yes.
Yeah, okay.
But
9, 9. Oh, sorry. There we go.
so they add up to 18, which is a multiple
Which
of
is a multiple
3.
of 3.
And the
It's even.
the number in the ones column is
It's
even.
even. Brilliant. Okay. So, Charlie, we're going to give everybody a little bit of a chance to have a go at a range of examples of multiples of 6 because we think there's a little bit more to think about here. So we are going to set up some challenges for you. We're going to show you the visualizer again. And here we have listed some challenges for you to be thinking about. And rather than you posting your solutions straight away in the chat, please could you not post anything at all until we invite you to. We don't want to give away any spoilers. So let's just explain our notation here. So we've got here, what we're saying is that the 6 and the 2 are the 2 digits you've been given, and you're going to add one more in to make the biggest possible multiple of 3, a 3-digit number, the biggest possible 3-digit number that's a multiple of 6. I said 3, didn't I? Multiple of 6. I'm so sorry. So here you're given a 9 and a 1, here you're given a 7 and a 2, and you're making the biggest possible 3-digit. D, E, and F are challenging you a little bit further. This time, you're being invited to include 2 digits of your choice to still make the largest possible multiples of 6. So let's give you a few moments, have a think in your class, work with somebody next to you, and then in sort of, let's say at around about 10:30, shall we? We will invite you to post some of the solutions that your class has offered. Probably the easiest way to do that would be to write A and then give us the 3-digit number.
Just to be really clear about the last three. So for D, you've got a 2 and a 5, and you can choose any 2 digits that you like.
Yeah.
As long as the 4-digit number is a multiple of 6. And the 2 digits you choose don't have to be identical.
No,
You
but
can
they
choose
could be if you wanted them to be.
Yes.
So off you go. Year 6 at St Paul's, you've raised your hand. Would you mind typing your question? If you've got a question, would you mind popping it into the chat and we'll try and respond? Don't worry. It's not quite past, but teachers, if you would like to post some of your class's solution, we'd be delighted to see them on the chat, please. Please don't forget to tell us which challenge you're looking at. It would be helpful if you just wrote A, B, C, D, or E, or F next to your solution. I'm not firing on all cylinders this morning, am I?
It's Monday morning.
It is a Monday morning, yeah. Mm.
One posted 642 for A, but I think there is a bigger number you can get.
The lovely thing about our interactivity, which we should credit our colleague Oscar for creating, of course, is that as you've seen, you can check your solution, and if you're not quite at the largest solution, you'll be told that there is a larger one, but it still won't tell you what the solution is. So we're hoping that will challenge you to continue thinking. Charlie, I wonder whether it's worth us having one go at one of either D, E, or F with the 4 digits. Do you think? Or
Yes.
Shall we
Yes.
have a little go at one of those, because we haven't done one of those before? And then okay. Do you want to take a pick, Charlie? Which would you prefer? Do you mind?
Okay, tell you what, shall we just give the feedback for A, B, and C?
Wait, that's a good idea. Sorry.
Well,
Yes.
Classes who know.
I mean, they can get feedback from the interactivity, but yes,
Yeah,
go
but
on.
they don't have the interactivity.
True. Okay.
Okay, I think A is 672. Okay, let me write it down. I think
I think it's 7.
no, 762
Yeah, good. Yeah.
because they're up to 15
Yeah. And then we've got the even.
and we've got it's even. I think the next one is 918.
Yep.
Uses the 9 and the 1.
Mm-hmm.
The whole thing gets up to 18.
Yeah.
And it's an even number. And the next one is going to be 972.
Yep. Even with a total of 18, the digits. Yep.
And the next one, I've got 2 and 5, which is up to 7.
Mm-hmm.
I'm going to put a 9 in the thousands column.
That seems like a good strategy.
And then, so I've got 7 and 9.
So that's 16.
16. I can't add another 9 because that'll up to
That would be
25.
But
I can
an
add
8 would be 24, wouldn't it?
So, and I can get an even number by
Nice.
putting this
2. So 9,852. Nice reasoning. Yeah.
And
Nice.
I think the next one's going to be, I hope I got this right.
Because we've got a multiple of 6. Sorry, a multiple of 3 already with the 3 and the 3.
So I don't have, I need an even number to
So I
go
couldn't
there.
put a 9 there. Yeah, I agree.
I think that's fine. And I'll let everybody do the
Do the
last
last
one.
one.
And
Okay, we'll let everybody do the last one.
fight over it.
Fantastic. Okay, so Charlie, we haven't got long left, but I think what we would love to do is just take you back to the interactivity, because there is so much more that you can be exploring back in school. This was our multiple of 6. So what we could do, Charlie, is we could look at multiples of 4, for example, if we
Yes.
wanted to. Should we have a quick think about multiples of 4? So if we, multiples of 4 are going to be even.
But they're not every even, are they? So
No.
you can have 2, 4, 6, 8, 10,
12,
14.
16.
So
Yeah.
some even numbers are multiples of 4 and some are not.
Yeah, so have you got a good way of figuring out whether a number is a multiple of 4?
So 24 is a multiple of 4 because when I halve it,
Yes.
I get 12. I can halve it again.
And still get a whole number.
And still get, whereas
Right.
22 is not a multiple of 4 because when I halve it, I get 11. And that can't be divided into 2 equal whole numbers.
Yes, nice.
And that sort of makes sense because if you can share something between 4 people, you can just imagine a pie, for example, cutting it into half and then half again.
Yeah, absolutely.
And
absolutely.
so 24 can be, you could do that with 24, but you can't do that with 22.
Right. That's really useful. So you might like to challenge yourself to have a go at some multiples of 4. Should we have a quick go at this one that we've got up here, Charlie? Or shall we look at the cog?
Do one, can you click on 4 again so we get slightly easier numbers?
Yeah, okay.
Okay.
So we've got a 4 and a 9. And we're looking for the highest possible even number that when we divide it by 2, we still get a whole, we can get another even number, so we can then divide by 2 and get a whole number again. Right.
Well, I know that 100 can be shared equally between 4 people. They get 4 25s.
And that's really useful, actually, isn't
So
it?
200 are going to be able to share equally between 4 people, and 300 and 400. So I can put the 9 in the hundreds column.
Know that that's going to be a multiple of 4. So that's really useful, isn't it?
I just had simple 900. I'd be
okay. So now I've got the 4 to use. So I know that 900. So really now I've just got to look at these 2 digits here and think about the highest possible even number that when divided by 2 also gives an even number.
I think I'm going to have 84 because that can be halved, 42, and then halved again, 21.
Okay.
So I'd be tempted to go for
84?
984.
Yay! Fantastic. Okay. And look, lots of you were agreeing with us there. So we're coming rapidly.
And some people wrote 948, which is also a multiple of 4.
But not quite the
highest. Because 48 can be split, halved, 24, and halved again, 12.
Yeah.
But 84 makes it slightly larger.
You'll notice that there's a purple cog up here in the top right. Quite a lot of our more recent interactivities have this purple cog. Clicking here will take you to the ability to change the settings of the interactivity. You could choose which multiples you'd like to work on. We'd really recommend 12s. There's some really nice work to be done, particularly now. Well, no, I'm not going to say anymore. You can change whether you're creating a 2, a 3, or a 4-digit number, and you can decide how many digits the computer gives you in the first place.
So can we just see? So you could do multiples. You could type a 12 there instead of the 2.
I could.
And you can have a target, well, 3 digits where you provided, which is what we've been used to.
We've been doing. Well, so we could choose 4 and be given.
You could be given 2 digits
or 3.
You could be 3 digits. And the 2 digits is what we've just been doing.
That's what we've just been doing.
Can we click on 3 just to see what it looks like?
Yeah, of course.
So we're not going to give people time to do this, but this is what it would look like. So some students might feel like being really challenged. And the reason we're choosing 12 is that all the numbers that, I mean, you could discuss this amongst yourselves and with your teachers. Multiples of 12 are both multiples of 3 and multiples of 4.
4. So we've
And we've
talked
talked
about multiples of 3.
we talked
We've talked
very briefly about multiples of 4.
Yeah.
So if you understand those two rules, you can challenge yourself with multiples of 12.
You're well equipped.
But you might not start with a 4-digit number. You might start with a smaller one.
No. So we hope you've enjoyed working on our dozens task, or at least getting a flavour of it. We hope you'll continue to explore. And as we said right at the beginning, we're going to be publishing more tasks over the course of this week. So teachers, do have a look at our Maths Week England page. The link is there. You can see on the Charlie, would you mind popping the link in the chat, please? That would be super helpful. But alternatively, you could just use our magnifying glass search and just pop Maths Week England into the search, and you'll quickly come across this page. You can see that we have got the link to dozens here, and tomorrow you'll find more links and on solutions to those tasks. Let me just show you how you can find the solutions. If we go to dozens, you'll see at the top, actually now the reason, I tell you why. Hang on a second. Let me just log out of here. And then when you as teachers, oh dear, I'm really struggling to get the right button here. Okay, so at the top of the dozens page, you will see that at the moment there is no solutions tab. So you can't be tempted to have a little look, but by Friday afternoon there will be a solutions tab, and you can have a little look about what other students have thought they're thinking as they've had a go at this task. The only other thing to mention, I think, is that we would really be grateful for your feedback. And so if teachers, you have an opportunity just to give us feedback in this evaluation form I've just popped on the chat, that'd be wonderful. And teachers, you will receive an email with that link as well. As you're aware, we're recording this webinar currently, and so the recording will also be popped up on our Maths Week England page. So if there's anything you want to refer back to, or you want to share the recording with other schools or other classes in your school, please do. Charlie, do we need to say anything else before we say goodbye?
We hope everyone enjoyed Maths Week England.
We do.
The other problems we've chosen are like this, like Dozen. They offer opportunity to do lots of mathematical thinking, explaining and reasoning, testing ideas out, conjecturing. This is all part of thinking mathematically. There is no reason to restrict working on these problems to just this week.
No, God, no.
Actually, there's so much maths to discuss, so you may want to spend some of next week as well, and then look at the solutions that we publish later on. Compare your solutions to the ones that we published. It's all part of sort of sharing and working collaboratively.
That's right.
We really hope you enjoy it.
We hope you have a lovely week and enjoy working on our tasks throughout. Yeah.
We haven't said, if you lose the link, you could just click on the magnifying glass.
Yeah, I did say that. Yeah.
You did say, sorry.
Yeah, no, don't worry. Yeah, so have a great rest of the week, and we look forward to welcoming you at a future webinar.
And we'll go on to creating more maths problems for everybody.
We will. Cheerio, bye, have a great day.